Geometry lesson 2-6A. We've been dealing more and more with finding proofs and theorems for different congruent segments. Today we're going to go with some angles as well, but still sticking with some of our congruent segment properties. First of all, just kind of going over some of the things we've already discussed. The fact about you should know at this point definition of perpendicular lines and any information that definition allows you to use. We have definition of right angles, 90 degrees. Segment addition postulate. When you take one segment, add it to another, it'll make the whole segment. Properties of equality. Addition, subtraction, multiplication, and division. If you do something to one side, you must do it to the other to keep things equal, balanced. The idea of substitution, replacing one value with another. The definition of congruent segments. If you have the definition of congruent segments, you have two values that are exactly the same. Alright? So we have UW and XZ becomes the line segment UW is congruent to the line segment X to Z. So what I'm saying is if you know that these two values have exactly the same length, then we know they are going to be congruent. So look at this very carefully. This one does not have the lines above it, and it says equals. This one has the line segments above it, and it now says congruent. So if I want to go from this statement to this appearance, that is the definition of congruent segments. If I have this statement and I want to go back to this look, that again is the definition of congruent statements. So be aware of those. We also have the transitive property. We've talked about that. If AB equals CD and CD equals EF, then basically what happens is the CDs cancel out and you've got AB equals EF. So that's the transitive property. Reflexive. If you're looking at this whole line right here, the distance from B to C is exactly the same as itself. It's a reflection of itself. And symmetric. Flip-flopping them won't affect anything. If angle A is equal to angle B, then angle B is equal to angle A. So again, that's just a flip-flop. Symmetric. Just like if you were to take an apple and cut it in half, both sides would be symmetrical to each other. Now, properties of angle congruence. This is a very similar definition to our properties of segment congruence. So we have angle congruency is reflexive, symmetric, and transitive. Meaning you could have two angles. You could have an angle that's going to be equal to itself. That's reflexive. You can have an angle that's equal to another one. You can flip them around because that's symmetric. And transitive, if I said angle A was equal to angle B and angle B was equal to angle C, so angle A was congruent to angle B, and angle B was congruent to angle C. From this standpoint, you could then say because of transitive, that angle A was congruent to angle C. Basically cutting out the B and being able to go from A to C. So that's transitive. Okay? So an example now. The more we can look at these proofs and theorems, the easier it will become, the more you'll start to recognize some patterns, similarities from one problem to the next. So here we have the given information. Angle 1. So we're going to be dealing more with angles. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And angle 2 is congruent to angle 3. So that's all the given information. We want to prove that angle 1 is the same as angle 4. Now think about what you have up here. 1 is the same as 2. And then later on 2 is the same as 3. So that kind of tells us that 1 is the same as 3. Then 3 is the same as 4, which is what we're looking for. So it's not that far off. You can logically see through it. Here is the situation in terms of the shape. Angle 1 is exactly the same as angle 2. That's why they both have a red mark in here. Angle 3 is the same as angle 4. That's why they have the same mark. 2 is the same as 3. So they all have the same marks because they're all the same value. We're trying to prove that 1 is the same as 4. Now you may not see it, but there are some triangles here. There's this triangle, and it overlaps with this triangle. So keep that in mind. In the future, that kind of thing might come into play. Okay, statements and reasons, two-column proof. First statement, given information. Angle 1 and angle 2 are the same as angle 2, and angle 2 is the same as angle 3. I got that because it's right here. Angles 1 is the same as 2, and 2 is the same as 3. Given information. We also know that by the transitive property, we would be able to cut these two out and say angle 1 is the same as angle 3. So 1 is the same as 3 over there. That's the transitive property. After the transitive property, we have given again that 3 is the same as 4. That was given information right here. 3 is the same as 4. And if you know that 3 is the same as 4, you can probably start to say, hey, the transitive property again. 1 is the same as 3. 3 is the same as 4. It's just like crossing those out and saying 1 is the same as 4. And now that we have angle 1 is the same as angle 4, we're done. That's all we were trying to prove. Angle 1 was the same as angle 4. So again, we took the given information. We were able to cancel these out because of the transitive property. We took some more given information. We could cancel out the angle 3's because of the transitive property again. They don't always have to be super complicated, but you need to know what you're starting with and what you're trying to do, your goal is, and then use your properties and theorems that you've been given to allow yourself to be successful. Okay, put some values in here. Measure of angle 1 is 63 degrees. 1 and 3 are the same, 3 and 4 are the same. What can you tell me about 1 and 4 right now? That they are going to be the same, they're congruent to each other because of the transitive property of congruent angles. Right? We're trying to prove that angle 4 is the same as 63 degrees. You don't need a whole diagram to look at this logically. If 1 is the same as 3 and 3 is the same as 4, then 1 is going to be the same as 4. And if 1 is 63, that means that 4 has to be 63. But we need to be able to look at it in terms of the diagram. So we know that angle 1 is 63 degrees. We also know that angle 1 and angles 3 are the same. So they have the same arc. And we know that 3 is the same as 4. And we're trying to prove that that is the same as 63 degrees right there. So we go through our statements and our reasons again. Number 1, all the given information. Angle 1 is 63, 1 and 3 are the same, 3 and 4 are the same. That's given. From there, we know that angle 1 is the same as angle 4. As we mentioned before, we could cancel those two out, and you now know that angle 1 is the same as angle 4 because of the transitive property. Then, the definition of congruent angles. Remember, I told you if you want to get rid of the congruent sign and make it equals, but still keep your same values, you're dealing with the definition of congruent angles. Before it was line segments, but the same is true. Notice the difference. There's no measurement symbol here, now there is a measurement symbol. They have no measurement symbol, now there is a measurement symbol. It was congruent, now it's equal. You interchange. If you saw this and you wanted to go back to this, that would be definition of congruent angles. If you're here and you want to go to this, it's definition of congruent angles. Because congruent angles will have exactly the same measurement. Now, we put in the fact that instead of measure 1 is equal to 63 degrees, which was given information right here, we can say that because measure of angle 4 is the same as the measure of angle 1, we can replace this value, this 63, can go right here. And we're now saying the measure of angle 4 is 63, which is exactly what we were trying to prove, so we have succeeded. Alright? So again, all right angles are congruent. If you are dealing with right angles, and anywhere else is a right angle, then you know you're dealing with congruent angles. Last example, given that angle DAB and angles ABC are right angles, so that's given, you now know that this is 90 degrees, and that's 90 degrees. You also know that they are congruent, because all right angles are congruent, so we know that these two are congruent to each other. Angle ABC is congruent to angle BCD, that's another piece of information. Try and prove that angles DAB and angle BCD are congruent to each other. So let's look at the diagram. So we have here angle DAB is a right angle, that's why I put the blue box here. Angle ABC is a right angle, so I put the blue box there. Angle ABC, A to B to C, is congruent to B to C to D, which means these angles are congruent to each other. If they're congruent to each other, that really means we have another 90-degree angle up there. And we are trying to prove that DAB, which is down here, trying to prove that this is equal to this. Which of course we know it is, because of the fact that it's 90 degrees. But let's look at our reasoning. So our statements and our reasons, number 1, DAB and angle ABC are right angles. Given information. So this angle is a right angle, and this angle is a right angle. Given. Next, because they are both right angles, we know that the two are congruent to each other. That's because our definition that all right angles are congruent. So we know we're dealing with congruent angles. Next, we throw in the fact that ABC is congruent with BCD, that these two, the red marks, were congruent to each other. So we know that. And our last step, if you were to cancel out, you know you have DAB, ABC, cancel out the ABCs, and you have DAB is BCD, which is exactly what we were trying to prove. So again, they don't always have to be complicated, but sometimes people have a hard time seeing what they're really after. There's a lot of given information and a lot of things that are really quite simple, and logically we were able to kind of talk through it anyway. It just takes practice and experience.